Okay, so we are looking electrostatic potential and capacitance chapter. So last class we have discussed about the physical meaning of this electrostatic potential. So in that we have seen that we know if there is a charge, q surrounding to this charge q, there is an electric field. So let me say this is charge q, this is charge q, let it be plus q. Okay, so surrounding to this plus q, we have electric field. So let me draw like this, a huge electric field. Now if you want to bring a charge, from somewhere else to at this point here, say example, let it be P. This point is P and this point is I can say Q. So I want to bring a test charge which is Q0 from P to Q. So the purpose is to bring the test charge, Q0 from P to Q. This is, let it be Q, small q, or we can say this is R, because this Q may be confused. This is point P and this is point R. From P to R against electric field, because when this Q0 moves towards plus Q, it experiences the electrostatic repulsive force. This plus Q repels that Q0. So if you want to bring the charge from point P to R, work should be done against that electrostatic force, repulsive force. Okay, so let it be called as F. See, let us have here one simple scenario. Say example, here you kept a box and the purpose is you have to push this box by a force F to a distance of some distance, let it be D. From this point to this point, we have to move this box. Now, to move this box, we have to do a work. To move this box, we have to give you a force from ourselves. So we need to do some work. So what is the value of work? So let it be, this force is equal to 50 Newton and this distance is equal to 3 meters. Let it be. What is the value of work done? Do you have any idea about that? If the force is equal to 50 Newton and with that force, if you move 3 meters, if you move the object to 3 meters, what will be the work done? Any idea? So we don't know how to calculate work done by knowing the force and distance. Yes, work is equal to force into displacement. Fine. So from that, you can tell me, right? You know the force, you know the distance. 50, I put 50 only. So it is 50 into 3, 150. What is the unit? So work is joule. Okay. So 150 joule. So simply speaking, work is equal to force into displacement. Force into displacement, F into D. It will be F into D. Now here also we have to experience a force, but here we are applying a push. So we are applying a push. So to push the object, we do some work, that is F into how much distance? D. The same way here we didn't give any force, but there is an opposing force towards us. There is an opposing force towards, not us, towards the charge Q0. So this Q0 is to be moved against that force. That means the force is electrostatic repulsive force, and how much distance it needs to move, that is R. So F into R only you have to multiply to calculate the work done. Now the second question. So here you are simply applying 50 Newton. Because of that, it moves 3 meter. Fine, 50 into 3 you multiply. Now, in some cases, let me assume one scenario. Say example, there is a car. Okay, so it just stayed on the road. Okay, so we have to push this car. To move a distance of some, let it be 10 meter. We have to move this car. It can't run. Okay, so 2 to 3 people combine together and they have to push this car to make a movement. So for that, initially they are applying the force of 1000 Newton. To make the car to move. Okay, once it starts to move, do they need to give the same 1000 Newton, or do they need to maintain the same 1000 Newton to move the car, or the requirement of force, or will the requirement of force gets reduced? Hope you get my question. Say example, a car is just stayed on the road. Okay, let you assume that it stayed on around 10 to 15 days. It just stayed on the road. It can't run. Okay, so it's just halted. So what you have to do? We have to move that car to approximately 10 meter. So in that the combination of 2 to 3 peoples are trying to push this car. So they initially apply 1000 Newton. The car starts to move. After that, do they need to maintain the same 1000 Newton to move the car for the 10 meter, or the requirement of force will get reduced? Initially 1000 Newton. After that, do they need to provide the same 1000 Newton or less than that? That's what I'm asking. Less than that, because initial push only is high. So to move from here to here, they are applying 1000 Newton. Then from move to here, they are applying just 900 Newton. Let it be. To move to here, they are applying 800 Newton only. To move to here, they are applying just 700 Newton only. And the same 700 Newton they applied throughout the 10 meter. If this is the scenario, so here force is not the constant value. Here Force is not the constant value. Force is changing. Force is changing with respect to distance. Am I correct? With respect to distance. So in this scenario, how can we calculate the work done? Here, just 50 Newton we applied. Here, just 50 Newton we applied. So it moves 3 meter, fine, 150 Joule. But here, we didn't apply a constant force, not 1000 Newton, not 900 Newton, not 800 Newton. It keeps on changing with respect to distance. So in this scenario, how to calculate the work done? Ashik, you have to know the answer for this question. Do you know it or not? Which technique we need to use for this? It's like final minus initial means which one you need to take as final, which one you are taking as initial. Here the 1000 Newton, here I am just putting 1900. 700. So 1000 minus 700 means 300 Newton only. Final minus initial means it is 700 minus 1000 now. See, because of that 1000 Newton, it just moves. Sorry, as an example, because of that 1000 Newton, it moves for 0.5 meter. Once it moves 0.5 meter, then the requirement of force will get reduced. Just 950 Newton is enough. Then because of that 950 Newton, again it moves 0.5 meter. Then again the requirement of force will get reduced. Then now we applied 900 Newton. Like that it goes on. So each distance the car moves, the requirement of force is always get reduced. So in this case, which technique we have to use? That's what I'm asking. I'm not asking the formula. I'm just asking the which method or which technique we have to apply to find the work done in this scenario. Which one you need to use? Pooja, are you there or not? I'm asking both of you only. Do you understand the question or not? Then, so what's your answer? We take average. Yes. Yes, tell me. We take average. Yes, that's the exact scenario we have to do. We have to take the average force. But that average force, how can we calculate? From which method we can calculate that average force? Because it's not uniformly varying, right? It's not uniformly varying. If it is uniformly varied, then you can take the average. If it is not uniformly varying, how can we calculate the average? Yes. What about Pooja? Okay. So Pooja, what's the distance between your home and your school? How much distance from your school and your home? Approximately only I'm asking. This is also you don't know. Approximately how much distance from your home to school? Okay, let it be 40 kilometers. 40 kilometers. So to travel this 40 kilometer, how you are traveling this? How you are traveling from your home to school? Basically, normally, huh? Bus. Okay, how much time that bus takes to travel this 40 kilometer? Hmm? So in huh? Are you sure? 30 minutes. Okay, 30 minutes. So 30 minutes. Okay. Now, so this is half an hour, right? Half an hour. Now, can you tell me the speed of your travel? Because you are traveling 40 kilometer in half an hour. So, what is your speed? How to calculate the speed? How to calculate the speed? Do you know the formula for speed or not? Then you know the distance, you know the time, then just tell me. Why you are taking so much time? Ah, hmm? Yes. What's the distance here? Just tell me what is the distance first. What is the distance I'm asking? 40 kilometer. What is the time? 30 minutes means you have to use in hour only, right? Kilometer per hour only the unit in the speedometer. Hmm? Have you looked at the speedometer or not in your bike or car? Hmm? So what is the unit in that? Kilometer per hour. So how much hour it is? How much hour? 30 minutes mean how much hour? 30 minutes mean 1 hour. What is that? Huh? Half an hour. So it is 1 by 2. So now what is the answer? If you divide 40 by 1 by 2, 80 kilometer per hour. So this is the speed of your travel. Now tell me, so do you drive bike? Hmm? No. Okay. So do you know what is 80 kilometer per hour? Do you know what is the speed of what is the meaning of that 80 kilometer per hour? 80 kilometer per means you can assume that at how much speed you can travel. Can you assume that? Okay. Now tell me whether your bus maintains the same 80 kilometer per hour throughout the entire travel from your home to your school. Your bus is moving on the 80 kilometer per hour only, or the speed is varying, or it travels in the varying speed, or it travels in the constant speed. Varying speed. Then what is this 80 kilometer per hour? That's what you are getting, right? From your formula you get 80 kilometer per hour, but your bus moves sometimes 40 kilometer per hour, sometimes 100 kilometer per hour, sometimes 90 kilometer per hour, like that it moves. So what is the meaning of this 80 kilometer per hour? So you got 80 kilometer per hour, right? As per your scenario, that is the correct thing. 30 minutes, I am traveling 40 kilometer in 30 minutes. Okay, fine. 40 kilometer in half an hour. So speed is as per the formula 80 kilometer per hour. So my question is it, so it is the initial speed. So after that, speed will get increased or decreased. Is this the initial speed? So when you just step down your bus, the bus immediately starts with kicks with 80 kilometer per hour. Is that correct? Is that what you are saying? It's average speed. It's average speed. The same thing also here as it's told that, so we have to use average force. Average force. But that case, in that case, if you want to find speed, we just need to listen carefully. If you want to find speed, let it be velocity v, distance by time. So practically our speed won't be constant. It will be varying one. It will be varying one. So for speed, I am telling 80 kilometer per hour means it is the average speed. It is not the actual speed. It is the average speed. So my speed may be 30 kilometer per hour, 40 kilometer per hour, 50 kilometer per hour, 60 kilometer per hour, 80 kilometer per hour, 100 kilometer per hour, 120 kilometer per hour also. Different time, it travels in different speed. At different time, it travels in different speed, so that I just calculate the average speed. That's what 80 kilometer per hour. Is that correct? Is that correct or not? Okay. Now assume that you have the data of speed. You don't know how much distance you are traveling. Say example, you just start with your home. Let the initial time, say example, you start at 10 o'clock, morning 10 o'clock. Let me assume that that is the initial time, t is equal to 0. You are traveling for approximately 2 hours. 2 hours. So at 12 a.m., you traveled in the bus or car, you can assume anything. Okay. So you are starting from your home. The initial time is t equal to 0, and you are traveling for 2 hours. So at 12 o'clock, you reached some distance. You have reached some distance. So my question is, I want you to calculate the distance. I want you to calculate the distance you traveled. So you don't know in your car, or you don't know the how much distance you are traveling. You don't know in your car or in your bike, the speedometer, the odometer. Odometer means the meter which shows the distance traveled. That doesn't work. That doesn't work. Which one? You can't find the, you can't get the how much distance you traveled. So what do you have to do? You have to calculate the distance traveled. But to calculate the distance traveled, what you are having the speed value. So at different time, you are traveling in different speed, right? That speed data you are having. So initially you start with 0 kilometer per hour. Then here 20 kilometer per hour. Here 90 kilometer per hour. Like that, at each point, you are traveling in different speed. That speed values you are having. Now total time also you know. So two things. Speed value, you are having the speed values at different time, and also you are having the total time. Now I want you to calculate the total distance traveled. Now in this case, you told that this is my average speed, but here you don't know the average speed. I want you to calculate the average speed. Then if you find the average speed, you can easily calculate the distance. So how can we calculate the average speed, or how can we calculate the distance? This is my question. Both of you understand my question or not? Pooja, you understand, or you want me to repeat? Repeat the question. Now the question, what is the question? Just tell me, what is the question? Hmm. To find the distance is the my aim. Okay, my motto is to find the distance. To find the distance, I need to find average speed. Okay, I need to find average speed. So but that is not easy thing here, because we don't get the uniform speed value. Speed maybe sometimes goes upward, sometimes goes downward, so it fluctuates. Okay, based upon the road, based upon the traffic. So depending upon the driving skill, it fluctuates heavily. So in this case, we have to find the average speed. Average speed. So for these kind of scenarios, we are using one tool in mathematics. That's what I'm asking. What is the tool? When one parameter is continuously changing with respect to another parameter, when one parameter is continuously changing with respect to another parameter, which tool we have to use in mathematics? So I just tell the area of the answer. I just tell the in which area you have to tell the answer. So I'm not asking the answer. I just want to know the topic. From the topic, we can find the answer. Which topic we have to use in mathematics? Yes. Hmm? You don't remember. Hmm? In first lesson itself, I told you many times. Hmm? At the entire physics, I will asking the same question. The same question I'm going to ask in each and every chapter. No, I'm not asking the answer from you. I'm just asking you to remember the form, the topic, the name of the heading. That's what I'm asking, but you said you don't remember. Hmm? When one parameter is continuously changing with respect to another parameter, listen carefully. If you, in anywhere physics, if you have this scenario, when one parameter, like in our case, force is continuously changing with respect to distance. Like here in this example, speed is continuously changing with respect to time, or distance is continuously changing with respect to time. So when you multiply or divide the two parameter, and the two parameter is changing with respect to one and another, the two parameter is changing with respect to one and another, then you have to use the concept of calculus. Concept of what? Calculus. In calculus, we have two major topics. Do you know that? At least tell me that also. Differentiation and integration. Differentiation and integration. So where I need to use differentiation, where I need to do the integration. When you want to divide the two parameters, that two parameters is changing with respect to one and another. In that case, you have to use differentiation. When you want to multiply two parameters, but that parameter is keep on changing with respect to one and another, in that case, we have to use integration. See here. Just note it down. See, but this is not the exact speed we are traveling throughout the entire travel. Maybe we touch 80 km/h at some point, but that doesn't mean that we always maintain that 80 km/h throughout the travel. Our speed value is keep on fluctuating entire travel. Say example, Pooja, tell me any place in between your home and school, any stop or any place or any name. Anyone in between your home and school? Okay, so it will be Ashik house. So say example, from your home to Ashik house, how much distance it will be? So you started at, let it be 7 a.m. So it will be at approximately 7:30 a.m. You should reach your school. Okay, so this is 0 times equal to initial time, t is equal to 0, and this is t is equal to half an hour or 30 minutes, you can take whatever. But as per your statement, R6 school, R6 house is at exactly 20 km from your house. Now, let me assume that from your school to from your home to R6 house, you are traveling 20 km. For that 20 km, so 7 a.m. you starts. Okay, so 7:30 a.m. you reached. So this is 0 km, and this will be 40 km. At in between somewhere else 20 km, you have Ashik house. So as if we travel at the constant speed, we should reach Ashik house by 7:15 a.m. Am I correct? But that doesn't always true in all cases, right? That need not to be always true in all cases, because we won't travel in the same speed. Initially, we will be traveling in higher speed, or laterly we can travel in the higher speed, depending upon the topic. So, depending upon the situation, we may reach the Ashik house either sometime in 10 minutes, we can reach the 20 km. So, just 10 minutes is required to reach 20 km, and the balance 20 minutes are required for to reach the balance 20 km. Or sometimes we may reach his house at 7:20 a.m. So 20 minutes for his house, and 10 minutes to travel for from his house to school. Asik, tell me how much time will it take to travel from your home to school? How much time will it take to travel from your home to school? Normally 10 to 15 minutes, yes. So maybe sometimes 15 minutes, sometimes 10 minutes. So if the time required is 10 minutes, means that distance time taken by the bus from Pooja house to Ashik house is 20 minutes. Is that correct? If the time taken for you to reach 10 minutes means, then automatically Pooja house to your house takes 20 minutes. So that time is keep on fluctuating. So let me take one scenario. Okay, let me take one scenario. So I want you to find the exact speed. I want you to find the exact speed at 7:15 a.m. Maybe 7:15 a.m. we may at Ashik house, or we may before Ashik house, or we may after Ashik house, that we don't know. But I want you to calculate. The bus is moving. Bus is moving. So you have to tell me the speed at 7:15 a.m. You have to tell me the speed at 7:15 a.m. So what is the only source? You have to go to near to the driver's place, and you just look at the speedometer, and you can tell the yes, at that time speed is 70 kilometer per hour, or at that time the speedometer shows 100 kilometer per hour. Like that only you can tell. Am I correct? So I want you to find the exact speed at 7:15 a.m. I want you to find exact speed at 7:15 a.m. So in that case, what is the only option? You just have to go to the near, you just have to go near to the driver place and look at the speedometer and tell me that yes, 7:15 a.m. the speedometer touches, or the speedometer shows 150 120 kilometer per hour, or 100 kilometer per hour, or 70 kilometer per hour. In that manner you can easily tell the exact speed at 7:15 a.m. Am I correct or not? Am I correct or not? Okay. In that case, say example, if that speedometer is not working, if that speedometer is not working, the only way you can find the speed is by using mathematical calculation. But the mathematical calculation we shouldn't put for the entire travel. We have to put the mathematical calculation at exactly 7:15 a.m. We have to find the distance by time at exactly 7:15 a.m. 7:15 a.m. means that it be t is equal to just 15 minutes. Am I correct? Or t is equal to, if you want to tell in hours, it will be 0.25 hours. When the t value is equal to 0.25, I want you to find the speed by using mathematics. So what is the only option? Distance by time. What is the only option? Distance by time. But distance means it should travel from one point to another point. Time means for that traveling, you have to find the time. Am I correct? Am I correct or not? So, but here I'm asking you to find the speed at one point. Say example, let it be, this is time, this is distance. If this is time, if this is distance, so at time t is equal to 0, you are at 0. So at 30 minutes, or 30 minutes or half an hour, whatever you can take, you just reach 40 kilometer. So this was your initial point, this was your final point. So the travel may be like this, or the travel may be like this, or the travel may be like this. So any curve it can takes. But if you travel at the straight line, this means the straight line denotes the uniform speed. If you travel at the uniform speed, that will be the straight line. Each time you are traveling in the same distance. So 30 minutes mean exactly, if you are speaking about 15 minutes, you will reach 20 kilometer. At 7.5 minutes means you will be reaching 10 kilometer. So you will be traveling uniform distance in uniform interval of time when you travel at the constant speed. But that is not the case. We can't travel in the constant speed. Initially our speed will be low, and after that our speed will be high, or initially our speed will be high, after that our speed will be low. So we don't know. So approximately, let me say, this is my speed and distance graph. This is my, if I say this is my speed and distance graph, that means at 15 minutes I just reach only 10 kilometers. For assumption I will take, in 15 minutes I just finish 10 kilometers, and the balance 15 minutes I cover the entire travel. So this graph tells us that initially you are traveling in low speed, and after 15 minutes you are traveling in highest speed. Now the purpose is we need to calculate the speed at this point. We need to calculate the speed at this point. That's our purpose. Do you understand the requirement? Both of you understand the requirement or not? See, this is you have to learn in your +1. In your +1 subject, this is the first in second chapter in mechanics. You have this concept how to find the how to use the calculus to find the exact speed. Exact speed. So let me zoom this graph. So this is the graph. So I just zoom this. So I want to calculate distance at this position. So distance. So in x-axis, I'm taking time. The time is t, and the distance is, let it be x. Sorry. Distance is y, and time I just take it as x. Time value I just take it as x. Distance value I just take it as y. Okay. Now at this time, that is x is equal to 15 minutes, you may travel 10 kilometers. But you can't, if you want to find the speed, you can't put 10 by 15. That won't be correct because distance is 10 kilometers, time is 15 minutes. Shall I do 10 by 15? Yes, you can do 10 by 15. But this is the average speed. This is the average speed from t is equal to 0 minute to t is equal to 15 minutes. So this is the average speed of this travel. If you just use 10 by 15 means, 10 by 15 means, it will be the average speed of from this point to this point. But that is not our requirement. I want to find the exact speed at this point. Exact speed at that point. So for that, what I have to do, I have to take a small distance and small time. That is change in distance by change in time at t is equal to 15, near t is equal to 15. That means change in time means let you take 15.000000 etc. infinite 0, put 1 minus 15. That means from 15 minutes to the immediate next second, how much distance you will be traveling. Say example, so in 15 minutes you travel 10 kilometers. In the next second you may travel 10.0000 some etc 0, maybe 4 or maybe 5, whatever, minus 10. This is what the exact speed at t is equal to 15. Both of you get this point or not? If you want to calculate the speed at 15 minutes, what you have to do, what you have to take, you just find the time difference between 15 minutes to the immediate next point. What is the immediate next point? It is mathematically speaking, it is 15.000000 etc. infinite 0, put 1. That is 15 to the immediate next point. In 15 minutes, I finished 10 kilometers. Yes. No, you can't. Yeah, you can take 15.1. Immediate next point, you can take 15.1. But again, it also the average speed between 15 to 15.1. If you want to calculate the exact speed at 15, your speedometer also doesn't show the exact speed. It is also showing the average speed between the one rotation of the wheel. The speedometer, what you are looking at your speedometer is the speed traveled in one complete rotation of the wheel. So in one complete rotation, say example, one complete rotation of wheel. Say example, if this is the wheel means, if this is the your vehicle wheel means, at one complete rotation, it may move some centimeter or it may move some meter in one complete rotation of that wheel. So what the speedometer shows, actually, each rotation, it just calculate there is a sensor to calculate for each rotation how much time takes place for each rotation. So it just divide that distance. Distance means For each rotation, the circumference is the distance. So if the wheel is rotating means, what the speedometer is showing, that's what I'm telling here. What I'm explaining here, if the wheel is rotating, for one rotation of the wheel, your vehicle moves the distance that is equal to the circumference of the wheel. For one rotation of the wheel moves at a distance that is equal to circumference of the wheel. Am I correct or not? So the circumference of the wheel already fixed, that already fine, we know. So what that speedometer do? The speedometer have a sensor. That sensor just calculate for one rotation of wheel, how much time will it takes place. Maybe it will be 0.1 second, 0.3 second, 0.5 second. So what will it do? In that speedometer, will be a microprocessor or whatever, something will be there. So that just divide that fixed circumference to the immediate calculated value. So that value only is shown as the speedometer. Speedometer. So speedometer is also showing the average distance between this point to this point. That means, so say example, in once the circumference of your wheel is 100 centimeter. Circumference of wheel is 100 centimeter means the speedometer shows the average speed in between this 100 centimeter. So that is enough for us. That is the accurate speed only for our calculation. That is the accurate speed only. But mathematically, if you are speaking, we have to calculate the exact speed at that particular point. That speedometer, nothing, no instrument in this world can't do this calculation. Can't do that calculation. Say example, if you just change the wheel of your vehicle, just fix the if you just fix the wheel which is smaller than the actual wheel, if you just replace your vehicle wheel with smaller diameter wheel, then the value shown by your speedometer will be wrong. Do you understand what I'm saying? If you replace your vehicle wheel with either greater diameter or smaller diameter, if you replace your wheel with either greater diameter wheel or smaller diameter wheel, then the value showed on your speedometer won't be correct. It will be wrong only, because the speedometer is tuned for your original wheel diameter. If you alter the wheel diameter, automatically speedometer can't read. Do you get my point? Do you get my point or not? So speedometer also doesn't show the exact value. So we can't put 15 to 15.1, barely okay, somewhat accurate only, but the exact accurate value is 15 to 15 point, immediate next point, 15 to 15.001. So at 15, we finished 10 kilometer. In the next 0.0001 second, right? In that time, how much distance you traveled, that is the matter. So that is what change in distance by change in time, which is dy by dx, which is known as, this is what we write it as dy by dx, that is differentiation of y with respect to x at t is equal to 15 minutes. So this, if you find the dy by dx, so if you want to find the dy by dx, you have to know the mathematical relation y is equal to x. That means you have to know the relationship between y and x. Y as the function of x, you have to find. If you know that, and if you differentiate that, and you substitute the t value, that means time value as 15 minutes, then you will get the exact speed. So that's what differentiation helps with that, helps with us. Both of you understand? Pooja? For Ashik, I'm explaining this for you second time. The same thing I am explaining for second time, and you are listening as the first time. And you completely forget about that. Okay. Pooja, do you understand? This is the concept which can be taught in 3 to 4 hours. We can't explain this concept in 10 to 15 minutes, but I am explaining for you in less than 10 minutes. I'm trying to explain this concept in less than 10 to 15 minutes. So if you don't understand, let me know. So the purpose is you have to understand the meaning of dy by dx. The problem is here, the y value is keep on changing with respect to x. That's okay. The distance value is changing with respect to x, but it is not changing in the uniform manner. It will be changing in the irregular manner. So in that case, at each and every point, the change should be calculated. The change should be calculated in the micro level. Okay, so that's what the dy by dx speaks. Dy by dx means for a small change in x, keep in mind, for a small change in x, what is the change in y? For a small change in x, what is the change in y? For a small change in x, what is the change in y? So that's what you have to remember. So when you divide the two terms, so I'm just dividing distance and time, but this distance and time are varying with respect to one and another. Then what you have to do, we can't simply divide distance and time. We can't do the simple division. What we have to do, we have to do for a small change in this time, what is this small change in distance? That's what we have to divide. So that is the exact differentiation. Is that clear or not? So whenever we have the situation like division of two parameter, whenever we have the situation in physics, that is division of two parameter, in that two parameter, they are changing with respect to one and another. If the two parameters are changing with respect to one and another, then what we have to use? We have to use the differentiation concept. Is that clear or not? Pooja, every time you want me to repeat your name, huh? Both of you only I'm asking, huh? Okay. So now, so division for dividing. So the purpose is, if the purpose is division of two parameter, then you have to use differentiation. If the purpose is division of two parameter, you have to use differentiation. Now, the same thing in the opposite side. The second case. The second case. So what is the second case? In that second case, okay, I know. Just 5 minutes, I will finish. In the second case, I know the distance traveled. I know the distance traveled. I'm sorry. I know the speed of my travel. I know the speed of my travel. I know the time value. So I'm starting at time t is equal to 0. I ended up with how much time? 30 minutes. So I know the speed at here. So let it be speed at here. Here speed will be 10. Here speed will be 50. Here speed will be 70. Here speed will be 100. Again, here speed will be 0. So you know the entire speed of your travel. So the graph is in between speed and time. Graph is in between speed and time. So you are not traveling at the constant speed. You are just not traveling. So you have to find the distance. You have to find the total distance of your travel. So distance is equal to, the formula is speed into time. But the problem is speed is not the constant one. Speed is continuously changing with respect to time. So in first case, we found that speed is equal to dy by dx. Now the purpose is to find the distance. To find the distance. So say example, at time t is equal to 0, speed is equal to 0. So I'm traveling around 30 minutes. So in that 30 minutes, my graph will be like this. So uniformly, my speed is getting increased. And after that, at one point, it again comes to 0. When I reach the place, it again comes to 0. So this is my graph. So I want to calculate the distance from this graph. So what I have to take? So here, if I want to find dy, I can put, let it be speed is equal to v into dx. What is the meaning of that? For a small time, let me assume the small time dx. At that small time, how much distance, how much speed you traveled, that is v. That is v. So if you multiply this v with the small time dx, if you multiply this v with small dx, what you are getting? The small area, let it be dA, small area under the curve. Am I correct? Because if dx is very small, and if this is the height is v, if the height is v, if dx is very small, if the height is v, means the area which I mark here will be the rectangle. Am I correct? It will be the rectangle. Say example, if I take dx here, and this will be the b. Now the area marked here is again another rectangle, but some other rectangle. Am I correct or not? And I can also mark dx here. I can take small time dx here, and I can. So dx means that small change in time. For your understanding only, I am just dividing that. I am just zoom the dx only. But the actual dx should be like this. The actual dx should be like this. It is the single line. Single line means it will be the very small, minute thickness. So if you find v into dx, you are finding the small distance. Then if you want to find the overall distance, what you have to do? You have to integrate this. Integrate means like this. So this v dx means this is the small area. Like that, you have too many areas. So what you have to do? If you just add all those areas, then you will get the entire distance. So adding all those areas will give the total distance. Total distance is adding all those areas. Integration of v dx. Integration of v dx means, so in my case, this speed is changing with respect to x. In my case, speed is changing with respect to x. So I want to multiply speed into time. Speed into time, I want to multiply. Speed into time only I want to multiply. But the problem is this speed is changing with respect to x. So distance, as the simple formula is, distance is equal to speed into time. Distance is equal to speed into time. But the problem is the speed is changing with respect to x. So it is keep on changing with respect to x. So what I am taking, I want to find the small distance. I want to take the small distance traveled in small time. So that will be dy is equal to v dx. So dy is equal to v dx means it is the distance traveled in minute second. Like that, if I add all the minute seconds, so that will be y. So if you add all the vdx, because that vdx will be in at the different places, that vdx denotes the different small areas, that each areas denotes the small distance. If you add all those distance, you will get the total area under the curve. If you add all those distances, means you will get the complete area, like this. So each line tells us the small distance traveled in small time dx. All are different distances. So what do you have to do? If you want to find y, you just add all those vdx. vdx1, vdx at 2, vdx at 3. Like that, we have infinite vdx. So adding all those vdx will give the integration. Adding all those vdx. So the integration value clearly tells us this is the summation of all area. This is the extension of s. This symbol is the extension of s. S means summation. So the summation only is extended like a symbol in integration. So v dx. So this is the distance traveled. So similar to that, in our first case, we multiplied force into distance. So force is changing with respect to x. Force is changing with respect to distance. So what we have to take? We have to take the small distance called dx. For that, the work done should be dw. And if you want to find w, means you have to do the integration. Is that clear or not? If you have any doubts on this, let me know. Okay, just make a note of this and you can leave. And again, we will have the class at 5:30 as usual. Sorry, 4 p.m. வரேன் ஒரு 1 hour 2:30. Hello, hello.